Hi, this video is an additional input into how we understand the conversion between Celsius and Fahrenheit to Celsius. So first of all, please remember that again, water boils at 0 degrees centigrade if we are using the temperature scale in Celsius, and not boils, freezes at 0 degrees Celsius. But it freezes at 32 degrees Fahrenheit if you use the Fahrenheit scale. And then water boils at 100 degrees Celsius in the centigrade scale, but 212 degrees Fahrenheit in the Fahrenheit scale. So if you look at this, the steps from 0 to 100 is 100 steps. But here, from 32 degrees to 212 degrees, it takes 180 steps. So what that means is that there are 100 steps in Celsius for every 180 steps in Fahrenheit. Okay? So that is kind of an equivalent. It's saying that for every 100 steps in the centigrade scale, there is 180 steps in the Fahrenheit scale. So that means that if you have to convert the Fahrenheit scale to Celsius, all we need to do is multiply the temperature in Fahrenheit, multiply it with the conversion equivalent, saying that there are 100 steps in Celsius for every 180 steps in Fahrenheit. And the Fahrenheit scale here should cancel out with the Fahrenheit here. So that leaves you with Celsius. Okay? So that sounds good, except for the fact that, again, temperature is special because the zeros do not align. Okay? When you look at other units, like for example, I know that 1 cm is 10 mm. And if I have 40 cm, that's actually 400 mm. So they are not equal, right? Mm is obviously different from cm. 10 mm is 1 cm. 400 mm is 40 cm. But at least I know that when you have 0 cm, it's always 0 mm. Right? 10 mm is not 10 cm. 400 mm is not 400 cm. In fact, 10 mm is 1 cm. And 400 mm is 40 cm. But at least I know that at 0 cm, it's always 0 mm. Because after all, if 0 cm means no length, so if there's no length, no matter if you measure it in cm or in mm, it's always gonna be 0. So what I'm trying to say is the zeros are aligned, right? But in temperature, notice that the zeros are not aligned because when Celsius is 0, Fahrenheit is not 0. Okay? So that is different from the mm and cm because it looks like the Fahrenheit scale has an unfair advantage of 32 because when Celsius is still at 0, Fahrenheit is already at 32. So therefore, this is an advantage from the perspective of Fahrenheit. So therefore, to level the playing field, you have to take away that advantage. You have to remove that advantage first so that you can say that everything is fair. So, in fact, that is the reason why the formula for temperature from Fahrenheit to Celsius is this. What you need to do is you have to have the temperature in Fahrenheit and then take away the advantage, right? So that it's fair. And then once you take away the advantage, that's when you convert it to Celsius. So here it will be in Fahrenheit. The Fahrenheit here will cancel out, and that leaves you with Celsius. Okay? So again, understand the concept. The concept is just you're just multiplying it with the conversion equivalent. How many steps in Celsius are there and how many steps of Fahrenheit? But because the zeros are not aligned, you have to make an extra step of making sure that it's fair. Because Fahrenheit has an advantage of 32, you have to take away that advantage to make it fair again before you convert. Okay? Now, sir, what if I convert first before I take away the advantage? Is that possible? Well, yes. You are saying, what if I have the temperature in Fahrenheit and then I multiply it with the conversion, which is there are 100 steps of Celsius for every 180 steps of Fahrenheit, right? And then what happens is this Fahrenheit here gets cancelled out, leaves you with Celsius. So you are converting it to Celsius. And then after I convert it, I take away the advantage, which is 32 degrees Fahrenheit. in principle, you are still doing the same thing. It's just that you're converting it first before taking away the disadvantage, the advantage rather, the unfair advantage. The problem is when you do this, note that this term, because the Fahrenheit gets cancelled out, this becomes Celsius. And because this term is Fahrenheit, now you have a problem, because if you have Celsius here, you subtract Fahrenheit from it, it's not possible. You cannot subtract Fahrenheit from Celsius. Feel me? But in concept, in principle, it's still the same. It's just that you're doing, you are taking away the advantage first before converting. Here you're converting it first before taking away the disadvantage. In principle, it's correct, but in practice, it's not, because this will end up in Fahrenheit and this is in Celsius, so you cannot subtract Fahrenheit from Celsius. But you can subtract the disadvantage, but since this is in Celsius, make this in Celsius first. Okay? So, how do you make this in Celsius? Well, we know again that 32 degrees Celsius, we know again that for every 180 degrees Celsius, degrees Fahrenheit, there are 100 degrees steps in Celsius for every 180 steps in Fahrenheit. So if I do this, I convert the 32 degrees into Celsius, it will end up with 17.77777. Let's just round it off to 17.78 degrees Celsius. So therefore, what this tells me is that 32 steps in Fahrenheit is equivalent to 17.78 steps in Celsius. So therefore, I can totally replace this with 17.78 degrees Celsius. And if I do that, that is kind of okay, because now, remember, this term is in Celsius and this term is also in Celsius, so you can subtract them, right? So what I'm telling you is that it's okay whether you subtract the advantage first, the unfair advantage, before you convert, or you convert it first before you subtract the advantage. But if you subtract the advantage, then you use Fahrenheit because this is still in Fahrenheit. If you subtract the advantage first, use Fahrenheit because this is in Fahrenheit. But when you subtract the advantage after you have converted it, then you cannot use Fahrenheit anymore, because this is already in Celsius. You cannot subtract Fahrenheit from Celsius. So therefore, you have to subtract the Celsius equivalent of 32 degrees Fahrenheit. And again, looking at our solution, 32 steps in the Fahrenheit scale is equivalent to 17.78 steps in the Celsius scale. Again, this is not exact. This is actually 17.7777. It's a non-terminating, so we just round it off to the second decimal place. Okay? So what I'm trying to tell you is that, again, you have to understand this conceptually. So these two are valid. So let's make an example. So let's say I have a temperature of 100 degrees Fahrenheit. I want to know what is its equivalent in Celsius. So using formula number one, what we do is we take the Fahrenheit scale, subtract 32 degrees from it first before converting the whole thing to Celsius. So here, you take the given, which is 100 degrees Fahrenheit minus 32 degrees Fahrenheit times 100 degrees Celsius divided by 180 degrees Fahrenheit. And this becomes 68 degrees Fahrenheit multiplied by 100 degrees Celsius over 180 degrees Fahrenheit. The Fahrenheit cancels out. 68 times 100 is 6,800 divided by 180. And I have probably to take my calculator for this, to use the calculator. 68 times 100 is obviously 6,800, and then I divide that with 180, and the answer will be 37.777777. So let's round that off to 37.78 degrees. Remember, what is left is Celsius. Okay? So take note, using formula 1, our answer is 37.78 degrees Celsius. Okay? Now, what happens if you use formula 2, which is, again, convert it first before subtracting the advantage? Well, uh, that means I have to take the temperature in Fahrenheit, and then I have to kind of multiply it with 100 degrees Celsius for every 100 steps of Celsius for every 180 steps of Fahrenheit. And then I have to subtract 17.78 degrees Celsius from it. So again, replace, this is 100 degrees Fahrenheit times 100 degrees Celsius over 180 degrees Fahrenheit minus 17.78 degrees Celsius. And if I do this, that is 100 times 100, that's 10,000, right? 10,000 divided by 180. And again, I have to use my calculator for this. So 10,000 divided by 180, that sums up to 55.55555555. And again, let's just round it off to 55.6. And remember, Fahrenheit here cancels out, so that gives you Celsius. And then you still have this term, which is minus 17.78 degrees Celsius. And therefore, when you subtract that, so let me do that in my calculator, 55.56 minus, sorry, I did it wrong, 55.56 minus 17.78. Guess what? We get 37.78 degrees Celsius. So you see, this is a proof that no matter if you use this formula or that formula, you still end up with the same answer, because conceptually speaking, it's correct. Because here, you are taking away the unfair advantage in Fahrenheit first before you convert. Here, you convert it first before you take away the advantage. But again, because this whole thing becomes Celsius, when you take away the advantage, you have to use the Celsius version of 32 degrees Fahrenheit. And again, as I shown a while back, 32 steps in Fahrenheit is equivalent to 17.787777 steps of Celsius. So if you do that, you have the same answer. However, if you notice, again, I told you that this is really not 17.78. It's really 17.7777777777. So therefore, this is not exact. However, this 32 degrees Fahrenheit is exact. Okay? So what I'm telling you is, that's why in books, you always only find this formula. Because 32 is exact. This one, it gives you some errors because this is again 17.777777777777. So that's why this is not practically used. But my point is, I want to really delve deep into the conceptual understanding why it's possible. It's possible because you are just converting one unit to the other, just multiplying it with how many steps of Fahrenheit are there in every step of Celsius. But again, because their zeros are not aligned, you have to take away the advantage of the Fahrenheit. That means taking away 32 degrees Fahrenheit if it's still in Fahrenheit. But if it's already in Celsius, because this is already in Celsius, you have to take away 32 degrees Fahrenheit, but in Celsius terms. And 32 degrees, 32 steps in Fahrenheit is again 17.78 steps in Celsius. So that's why when you do it like this, it's not only more 32 Fahrenheit, but it's 17.78 degrees Celsius. But again, because this is more not exact, because this is 17.77777777 like that, and this is exact, books only remember that one. Okay? Now, aside from that, the same is true also with converting Kelvin to Celsius. So, if you have temperature in Celsius, what you can do is you can, remember in Celsius and Kelvin, 0 Kelvin, which is the coldest temperature that matter could have, is set at negative, or not set, is found to be, is calculated to be at negative 273.15 degrees Celsius. And again, if you look at this Celsius has a disadvantage. Kelvin has an advantage because, again, this starts at the starting point, while the Celsius starts negative 273 further back from the starting point. So this is an advantage. So therefore, every time you see Kelvin, you have to subtract the advantage. But every time you see Celsius, you have to add the disadvantage because he is the one that has a disadvantage. So the scale that has a disadvantage, you should add to it. The scale that has an advantage, you have to subtract from it. And how much do you subtract? How much is the advantage or the disadvantage? And again, the advantage and disadvantage is 273.15. Okay? And again, you have to remember that at 273.15 Kelvin, that is equivalent to 100 degrees Celsius. And at 373.15 Kelvin, that is equivalent, 0 degrees Celsius, rather. Then at 373.15, that's 100 degrees Celsius. So if you look at the steps, right? How many steps is this to this? That's 100. How many steps is 273.15 to 373.15? It's still 100. So therefore, for Celsius and Kelvin, it's kind of the same. There are 100 steps of Celsius for every 100 steps of Kelvin. So there's a 1:1 correspondence. And because of this, when you have temperature in Celsius and you want to convert that to Kelvin, again, Celsius has the disadvantage. And because it has a disadvantage, you have to give back, you have to level the playing field by adding that number. So you have to add 273.15 number to it before you convert. But, because this is in Celsius, meaning what you add should be in Celsius. Okay? And then you multiply that with the conversion equivalent, which is there are 100 steps in Kelvin for every 100 steps in Celsius. Like that. Right? So here you add the disadvantage first before you convert. But again, as I told you, it also works the other way. You could also convert first the Celsius, which is 100 Kelvin per 100 degrees Celsius. This cancels out, gives you Kelvin. And then you add the disadvantage. But in this case, it's not as complicated because remember, every 100 steps of Celsius is also 100 steps in Kelvin. So that means you are using the same number. Unlike in Celsius and Fahrenheit, that if every 100 steps in Celsius, there's 180 steps in Fahrenheit. So there is not a 1:1 correspondence. But for Celsius and Kelvin, every 100 steps in Celsius is also 100 steps in Kelvin. So therefore, it's just the same number. So therefore, if you add 273.15 degrees Celsius, you also add 273.15. But in this case, because again, this one becomes Kelvin. Remember, the Celsius cancel out. This becomes Kelvin. This is now in Kelvin. So here, what you add here is the same as here because again, every 100 Celsius is just 100 Kelvin. So therefore, 273.15 Celsius is still 273.15 Kelvin. I mean steps in Kelvin and steps in Celsius. So therefore, again, you do this. And again, you kind of have an option. You either add the disadvantage first, but if it's in Celsius, you add it in Celsius before you convert it. Or you could convert it first, but take note that when you convert it first, this whole thing becomes Kelvin. So when you add the disadvantage, it's already in Kelvin form. So these two formulas are also present in most books. But again, because of simplicity's sake, for simplicity, there's only one of them that the book would adapt. And again, they would adapt something like this, which is the easier form. Now, in most books, they don't even give you the unit. So it just gives you temperature in Celsius is temperature in Fahrenheit minus 32, no units at all, times 9 over 5. I'm sorry, 5 over 9. And again, this 5 is the 100, and this 9 is the 180. That's just reversed. And then to give the Fahrenheit, just gives you temperature in Celsius times 9 over 5 plus 32. And then to give the temperature in Kelvin, you just have temperature in Celsius plus 273.15. And then to get the temperature in Celsius, that's going to be temperature in Kelvin minus 273.15. This is what you usually found in books, in Wikipedia, in internet. And again, I kind of don't like that because it takes away the sense that you are just converting. And the sense of conversion is just you're just multiplying it with how many steps in this scale is how many steps in that scale. Similar to there are 1 step in centimeter for every 10 steps in meters. So therefore you have to multiply 1 cm over 10 mm or things like that. And again, it takes away the intuition, the understanding behind how temperature scales are set up. But yes, I do understand this is easier to memorize, right? And you probably kind of want to remember it like this. But again, if it's actually useful if you understand the temperature scale by heart. I mean, if you understand the temperature scale by heart, you can just derive this from what you know. Okay? All you need to learn is 0 degrees Celsius is 32 degrees Fahrenheit. 100 degrees Celsius is 100 degrees Fahrenheit. 100 degrees Celsius is 212 degrees Fahrenheit. And then you have to remember that 0 Kelvin is set at negative 273.15 Celsius. And then 0 Celsius is 273.15 Kelvin. And 100 Celsius is 373.15 Kelvin. And the rest, the formula, you can just construct them from scratch. Okay? So again, that's the idea there. Now, I'm not saying you should do this. I'm not saying you should all do this. What I'm saying is, if it's possible, understand this formula from the context of what I've just explained to you. Because again, it ties together a lot of stuff. For example, when you look at this formula, you don't scratch your head and say, why is the formula like that? I thought conversion is simple. I thought conversion is just, the unit you want to convert multiplied by the conversion equivalent, and then you get the answer, just like everything else. How come this is so complicated? It's complicated simply because the zeros do not align, unlike in other units. And again, it makes everything simple. Instead of thinking of temperature scale, which is separate from conversion of other units, now you have a framework where you think that all of this is just conversion. It's just that there's a special case for temperature because their zeros are not aligned. And again, for me, in the long run, it makes better sense to approach at the temperature, conversion of temperature and conversion of other units from that perspective, rather than just memorize this and not understanding why they are like that. Okay? So that's something to think about. But again, do not force yourself. If it's really difficult to kind of understand what I'm talking about, you can just memorize this. But again, understand that there's a deeper meaning. There is a very beautiful explanation why the formula is like that, and they don't just come out of thin air so that to make your lives difficult. There is a basis for understanding why the formula is like that. And in fact, I challenge you to make a conversion equivalent from scratch, from just how I explained this to you, to convert Fahrenheit into Kelvin and Kelvin into Fahrenheit. Not by using the Celsius as an intermediate, but by kind of remembering that 0 Kelvin is equivalent to negative 459.5 367.67 Fahrenheit, and the point at which it's 0 degrees Fahrenheit, it is equivalent to, let me look at my notes, 255.372 Kelvin. Okay, this is kind of the fact about Fahrenheit and Kelvin. 0 Kelvin is set at, or is found out to be at negative 459.67 Fahrenheit, and at 0 Fahrenheit it is at 255.372 Kelvin. So I challenge you, for anyone who likes to have any challenge, record a video of you explaining a formula that kind of converts Fahrenheit to Kelvin or Kelvin to Fahrenheit,